Dear students, welcome to the session. In this session, we are going to see the lab program number 3 and the flow chart. So, in order to understand the flow chart, just I will revisit the program. We will explain the program again so that your programming understanding and the flow chart that can be synced very well. Now, lab program number 3. So, this is develop a program to compute the roots of a quadratic equation by accepting the coefficient, print appropriate messages. So, in this particular program, what this program will do is it will solve a quadratic equation. And what is a quadratic equation? Quadratic equation is of the form ax square plus bx plus c is equal to 0. So, if we solve this quadratic equation for the x will have two roots. So, this program is going to calculate the two roots. And what are the input required for this program? The input required for this program is the coefficients, by accepting the coefficients. And in the quadratic equation generic form, ax square plus bx plus c is equal to 0. What are the coefficient? A, b and c are the coefficients. So, a, b and c will form as the inputs to our program, and we are going to take these three coefficients or inputs from the user. Okay, and after taking that inputs, we are going to do the calculation and calculate the roots of a quadratic equation. And let's begin with the program. Initially, we know we have to include the Stdio.h library, which includes the standard input output functions. So, hash include std, hash include angle bracket stdio.h closing angle bracket, hash include inside the angle brackets we have math.h. So, math.h we are using this additional library so that we can use some of the functions from this library. One is the square root and second one is the absolute value. So, we already are familiar with the square root of a number. The absolute value is nothing but the absolute value of any number is a positive number. So, absolute of, for example, absolute of 10 is equal to 10 and absolute of minus 10 is also equal to 10. So, irrespective of whether it is a positive or negative, the absolute, when we apply the absolute function, the output will be always the positive of that particular number. That's the absolute value. Those two functions we are going to use from the math.h. So, we have main parenthesis, pair of parenthesis, open curly brace. This is the start of the program, and there is a corresponding closing, that is the end of the program. Inside, this is the declaration statement. We have so many variables of a type of float. We need ABC for the inputs coefficients, and we need two variables x1 and x2 for the square root. Okay, for the root of the equation. X1 is one root, x2 is another root. DISC for calculating the discriminant, and in case of a imaginary roots, we need to represent the real part and imaginary part. So, I have a one variable called real and another variable called img. So, we have all the variables separated by comma and having a data type of a float ended with a semicolon. Now, first we will display a message to the user saying that the program requires the three inputs. So, printf. So, this is the display output statement. So, it will display enter the coefficients a, b and c of a quadratic equation. So, user will enter the three values a, b, c. And then using the scanf function, we will read the input value for a, b and c. So, how to use the scanf function? Scanf bracket inside the pair of double quotes we have %f, %f, %f. These are the format specifier of type float for variable a, b and c. And in scanf we should always prefix the variable with the ampersand, which represents the address of that particular variable. So, ampersand a comma ampersand b comma ampersand c closing bracket and semicolon. after this. Now first we have to make sure it is a quadratic equation. So if any of the value of a or b or c is 0, then we will not say it is a perfect quadratic equation, we will say invalid inputs. So we want to we will do the calculation only when a is not equal to 0, b is not equal to 0 and c is not equal to 0. So that is the first condition. If a is not equal to 0 and b is not equal to 0 and c is not equal to 0, okay, so all a b c are non-zero values. If that statement is correct, then this will become true. Okay, then it will enter the program. Let's say user has given the value of a as 0. So 0 not equal to 0, 0 not equal to 0 is a false. So if that statement is false, what will happen? So this is the opening curly brace of the if statement. So if you go down exactly, okay, this is the true block, closing curly brace of the true block, else. So if a is equal to 0, then the statement will become false. It will not execute the true block, it will execute the else block. In the else block, what we are saying? Invalid inputs. Okay, so first we will, so if any of the a value is 0 or b is 0 or c is 0, the program will just display invalid inputs and it will stop. If the all the given values a b c are non-zero, okay, if those are non-zero, then this statement would be true. It will come inside the true block. The true block will start from the open curly brace. We calculate DISC. DISC is equal to b square minus 4ac. So what is this? We know what are the two roots. The two roots of a quadratic equation, x1 is equal to minus b plus square root of b square minus 4ac whole divided by 2a, and x2 is equal to minus b minus square root of b square minus 4ac whole divided by 2a. So whatever is inside the square root, that is called as a discriminant, that is b square minus 4ac. So we are calculating the DISC or the discriminant b square minus 4ac. Why we are calculating this? Based on the value of DISC, there are three conditions. So DISC can be 0, DISC can be greater than 0, DISC can be less than 0. So inside this if true statement block, we have three more if statement blocks. So based on the value of the DISC, the first one, so we calculated the DISC value using a, b and c, b square minus 4ac. So DISC is calculated. If DISC turns out to be 0, this condition will become true. So for some reason DISC is equal to 0, then this condition will become 0. For example, if equation is x square, okay, x square plus 2x plus 1 is equal to 0. So here a is equal to 1, b is equal to 2 and c is equal to 1. So the equation again is x square plus 2x plus c is equal to 0. So what happens? B square, 2 into 2, b is 2, 2 into 2 minus 4 into 1 into 1. So 4 minus 4, this becomes 0. Then it will become, this condition will become 0. DIC will become 0. So this condition will become true. That time we will display roots are real and equal. And what are the roots are? Since b square minus 4ac is 0, we need not calculate the other side of the equation. So x1 is equal to minus b divided by bracket 2 into a, and x2 is equal to x1. You need not recalculate, or you can do the calculation, that is not a problem. And then you will print the roots. Roots x1 is equal to percent 4.2f. So 4.2f, or if it is confusing, just you can use percent f. Okay, the difference, only difference is 4.2 is like so it will use only the 4 places, and out of those 2 are decimal places. So just you can experiment using percent 4.2f or using percent f. So basically In this place it will print the value of x1, and x2 is equals to percent 4.2f. In this place it will print the value of x2. So how you will get the output? Roots x1 is equal to this and x2 is equal to this. So if you want to see the output, I will show you the output so that you can visualize how that output looks like. Okay, so if this is example, okay, this is x squared plus 2x plus c is equal to 0. Roots are real and equal, and roots is equal to x1 minus 1.00. So it will print 2 decimal places. X2 is equal to minus. This is how that DISC is equal to. This is the case when DISC is equal to 0. This is how you will see the output. Okay. Next situation is if DISC value is greater than 0, means DISC is a positive value, then what we will do is we will if this condition is true, it will come inside here and we print roots are real and distinct. Then our calculation is x1 is equal to, so if you see the numerator, we have the bracket for the whole numerator, minus b plus sqrt is the function. Sqrt, it is the function which is included in the math library, so you can directly use that. So how to use this? If you say sqrt of 4, it will return a value of 2. So we are what we want, square root of b square minus 4ac. B square minus 4ac is nothing but DISC. Square root of DISC minus b plus square root of DISC. This is the numerator, and what is the denominator? Again it is inside the 2 parentheses, 2 into a, so it is divided, so you will get the value. And what is x2? Only difference between x1 and x2 is this sign. Here it is plus, here it is minus. So we calculate x1 and x2. So if DIC is greater than 0, what that means? Roots are real, it is not imaginary, and they are distinct, their values will be different. So again same printf statement, roots x1 is equal to percent f and x2 is equal to percent f. Just 4.2 if you want to replace with just the percent f, you can do that. You will see the how the output display is different from 4.2. So you can try both. So it will display this x1 value here and x2 value here. So how this piece of code is executed, I will show you the output when roots are real and distinct. Okay, so this is the condition when roots are real and distinct. What is the input given? A is 2, b is 3 and c is 1. What is b square minus 4ac? B square is 3 square, that is 9 minus 4 into 2 into 1. So that is 4 into 2 is 6, 9 minus 6 is 3. So DISC is greater than 0. So roots are real and distinct. So roots x1 is equal to minus 0.50, x2 is equal to minus 1. That is how we get. Now the third condition is DISC value is less than 0. So this we just now we saw this part. Now DISC less than 0. If DISC is less than 0, we know that it is under the square root of DISC. Whenever we have DISC less than 0 means what? DISC is a negative number. So square root of a negative number is a imaginary number. So in this case, when we have DISC is less than 0, roots are imaginary. Roots are not real numbers, they are imaginary numbers. And how to find the roots? So we have to calculate the real part separately and imaginary part separately. And what is the real part? Minus b divided by 2 into a. This is the real part. And what is the imaginary part? Square root of. So it is on the whatever the square root part comes, that is a imaginary part. Since we cannot find the square root of a negative number, we have to convert this negative number to positive number. How to do that? We use another math library function called fabs. So this is a absolute value of the floating point numbers. So fabs of DISC. Let's say DISC is minus 10.2. Fabs of minus 10.2 will become 10.2. So square root of 10.2 divided by 2 into a. So it will give whatever the value that is as an imaginary part. So in C programming, we do not have a data types which will directly handle the complex numbers. Here, so what we have done is we calculated real part separately, imaginary part separately. But when we are displaying, we will display it as a imaginary number. So first root x1 is equal to real part plus I into imaginary part. Second root is real part minus I into imaginary part. So x1 is equal to what? Real plus I imaginary, and x2 is equal to real minus I into imaginary. Okay, I will show you the output so that it is easy to understand. Okay, you can see here, enter the coefficients. So 2 3 2, what happens? 3 square, b square is 3 square, that is 9, minus 4 into 2, 4 AC, A and C. 4 into 2 is 8, 8 into 2 is 16. So 9 minus 16, which will come as minus 7, square root of minus 7. So it is an imaginary number. So roots are imaginary. How to represent the roots? x1 is equal to minus 0.75 plus I 0.66. x2 is equal to minus 0.75 minus I 0.66. So if you see here, both the real parts are exactly the same, imaginary parts are exactly the same, only the sign will difference. x1 will have plus, x2 will have minus. Okay, so after that, so the program will come here if it is true, and if any of the value of A or B or C is a 0, then it will come here, it will say invalid input, and it will stop the program. Okay, so what are the possible inputs for this program? Suppose if you enter the input as 250, C is 0 here, so the first if statement becomes false, then it will display invalid inputs and it will stop, and rest of the inputs we have already seen, when roots are real and equal, real and distinct, and when roots are imaginary. Okay, now what we will do is we will compare with the flow chart, and we will understand the flow chart. So I will display the flow chart right beside this program. Okay, we have the flow chart here. Okay, so this is the lab program number 1. I will try to fit this. Okay, so we have the program and the flow chart side by side. I will just adjust and then we will start. Okay, so we have the program on the left hand side and flow chart on the right hand side. So this is the flow chart, lab program number 3, quadratic equation. So this is the start of the program, this is where we start the program, this is start, and we read 3 coefficients A, B, C. So if you want to have in the flow chart one more display operation here, display, enter the coefficients A, B, C, then you can include that block, or you can just leave that. So this both together. After that we have scanf A, B, C. Scanf is nothing but read coefficients A, B, C. After this statement we have a if statement. So if A not equal to 0 and B not equal to 0 and C not equal to 0. So after that we have a condition here, if A not equal to 0 and B not equal to 0 and C not equal to 0. So either this condition is a true or it can be false. So we want all this ABC should be non-zero. If any of this value is 0, that is, if this condition is false, what we are going to do, we have already seen that false. So if that condition is false, it will come here, print invalid inputs. So if this condition is false, display invalid inputs, and then the program will stop. And let's say if all the given values ABC are non-zero values, if this condition is true, means all are non-zero. If this condition is true, it will come inside the true block. We calculate DISC. Calculate DISC is equal to B square minus 4AC. After that, we come across the if statement. If DISC is equal to 0. So after doing the calculation, so we calculated the DISC, then this if condition is same as this if condition. If DISC is equal to 0, again there are two paths. If DISC is equal to 0, it will enter here and it will execute all this. If this condition is false, where the execution will come? Execution will come to the next statement, that is next if statement. So if DISC is false, it will come to the next statement, that is the next if statement. Let's assume DISC is equal to 0. If DISC is equal to 0, it will come inside. So display roots are real and equal. Display roots are you can have real and equal if you want. Then we calculate x1 is equal to x2 is equal to minus b divided by 2 into a. And after doing that, just I have clubbed these two into one statement. If you want, you can have two separate blocks, rectangular blocks. All the calculations should be rectangular blocks. Input and output should be a parallelogram, and rhombus should be used for the decision making. Now after doing this, it will print roots. Okay, the roots, display roots x1 and x2. After this statement is completed, it will come to this statement. So after this statement, it will come to the next if statement. So what is the next if statement? If DISC is greater than 0. So we have here, so it will come here, it is checking if DISC is greater than 0. Again, two possibilities, true or false. If it is true, it will come inside. So if DISC is greater than 0, it will come inside. Display roots are real and distinct. Then it calculates x1 and x2. So x1, the same formula whatever is here, minus b plus square root of DISC divided by 2a. x2 is equal to minus b minus square root of DISC divided by 2a. x1 and x2 are calculated. Display roots x1 and x2 and continue with the next statement. After printing this, it will continue with the next statement. And if this statement is false, if it is false, it will directly come to this statement. Okay, if this statement is false, it will skip this and it will come to next statement, that is the next if statement, that is DISC less than 0. That is the next if statement. Now if you see here, either you can give this equation as in the C format structure, or you can give like this. Okay, there is no hard and fast rule that you should give it in the C format. Why I am giving it in the C format is it is better for you, you can remember. Okay, don't try to give like this. So what happens is, when you are writing a C program, then it becomes difficult. So try to represent in this format only, which is exactly same as the equation here, so that for remembering the program also it will help. Now if this condition is false, it will go to the next statement, if DISC less than 0. So it will continue to A, and when it continues to A, so it is a connector. I told you before, the page is completing here. So at the end of the page, I will just draw one circle. I will label it as A, B, C, whatever label you want to do, X, Y, Z, anything is fine. On the next page, you start with the one circle. and give the same label. So it gives the connectivity between this and this. So what is the next if statement? The next if statement is we are checking if DISC is less than 0. If DISC is less than 0, that is true. Roots are imaginary. So we are saying roots are imaginary, and we are calculating the real and imaginary part separately. So real is equal to minus b divided by 2 into a. Imaginary is square root of fabs of DISC divided by 2a. So real and imaginary, which is exactly same like this. And after we will display the roots. So we are saying here display roots x1 and x2 in complex number form, that is a plus or minus jb. So we are just saying display it in the complex number form, and how to do that, that is done. It is here. You don't have to give this here, just you say display the roots in complex number format, that is a plus or minus jb format. And after doing that, once it completes this statement, it will come here. So it will come to the end of the true block of the if statement. After that, it will come to the end of the program. So after this statement, it will come to the end of the program. Let's say this statement is false. If DISC is false, then it will not execute this part. So execution will directly come to the next statement, which is end of the true block, and after that it will come to the stop. Okay, that is the end of the program. So if this statement is false, then it will directly come to the end of the program and it will stop.